Okay, we're going to spend a little bit of time thinking about making measurements in the lab and also how many numbers one needs to write down when you're taking measurements in the lab and doing calculations with those numbers. So let's set up this scenario. We have three different balances. So I have one balance here, and this balance is able to measure to the nearest gram. So I'm just going to write on the top plus or minus 1 gram. Then we have a second balance over here. And this second balance is able to measure to the nearest hundredth of a gram. So on this balance, I'm going to write plus or minus 0.01 gram. And then finally on this third balance, it's able to measure to the nearest 10,000th of a gram. So I'm going to write above this balance plus or minus 0.0001. And now we're going to imagine that I'm going to take an object and I'm going to place that object in all three of these balances, and we're going to measure what the mass of the object is. Now before I do that, I need to tell you that we carefully measured the mass of the object, and it happens to have a mass of 5.2372 grams. Make sure I got that right. Yep. So 5.2372 is the actual mass of the item that we're going to measure. So okay, we'll imagine it's these magnets. So okay, so the mass of these magnets is 5.2372 grams, and I'm going to place it on this balance. What is this balance going to record as the mass of this object? You might not be sure. Some of you are thinking, oh, it's going to be 5 grams. But some of you are wondering, I wonder if that extra on the end, somehow the balance will pick that up. So it might be 5 grams, or it might be 6 grams. Well, we'll just say the balance records it as 5. But the point here is we're not sure whether this is 5 or 6. We only know this measurement to plus or minus 1 gram. So really this measurement is 5 plus or minus 1 gram. Now we'll place the object on this balance. What's it going to measure? Well, it probably depends on how the balance is calibrated and other things like that. But we see that, okay, we know that 5 is going to be good. We know this 2 is going to be good. But when we get here to the 100th place, we're not sure if that's going to be recorded as a 3 or a 4. And we'll just say this balance records it as 5.24 grams. Some of you may have been thinking I was going to write a 3 here. The point is, we're not certain about this digit here. So we say we know this measurement to 5.24 plus or minus 0.01 grams. And then we finally go to this balance here, and well, this is going to record it faithfully as 5.2372 plus or minus 0.0001 grams, all the way out to the nearest, that's the tenths, hundredths, thousandths, 10,000th place. So we know this number all the way out here, but we're not sure about this particular number here. This might be a 3. It might be a 1. We don't know, because we didn't measure it beyond here. So the point is that different measurements carry with them different levels of what we call precision. So these all represent measurements of the mass of this object to different levels of precision. And we convey our knowledge of the precision of our measurement by how many digits we record. So this particular measurement only has 1 digit recorded, and that represents poor precision. This measurement here, relative to this one, represents a measurement that has much greater precision. And what we do is we count the number of digits written down, and we call those significant digits. So we would say this measurement has 1 significant digit. We'd say this number has 3 significant digits. and we'd say this number here has 1, 2, 3, 4, 5 significant digits. But it gets a little tricky. Let me give you an example of where it might get tricky. These should be easy. Let's do another one. Okay, so this often gets problematic when we have to deal with zeros. Usually if you just see a digit, you count it and it counts as a significant digit. So 1.23 seconds, for example, it's very easy to see that that has 3 significant digits in it. But what about if I write this? Let's leave it like that, 5.0 seconds. Or if I happen to write this. And let me talk a little bit about why this is the case. So let's, in this case, assume I have 3 balances. And in this case, well, let's just make it 2. Let's just make it 2. And in this case, this balance measures to the nearest plus or minus 1 gram. And this balance is not very precise. It only measures to the plus or minus 100 grams. And I'm going to take an object that happens to weigh 6,200 grams, and I'm going to place it to weigh 6,200 grams exactly. And I'm going to place it on this balance. Well, this balance was recorded as 6,200 grams. And we would say that because this balance measures all the way to the nearest gram, this is a measured number. It's a measurement that's been made. And so this number, we know this one, we know this one, we know that's a 0. And we're not real sure about this, but we count the first digit we're not sure about. So this measurement has 4 significant digits. However, if I place this mass on this balance, it'll also read 6,200 grams, but it's only good to plus or minus 100, which tells me I know this number's good, but I'm not sure about this one. And so this particular measurement would only have 2 significant digits. Because if I'm a little bit unsure about this number, I don't know anything about this one, and I don't know anything about this one. So these 2 zeros in this particular case represent numbers that aren't measured. We do not know if those are zeros or not. We don't know if that's a 2 or not, but we know it's pretty close to 2. Let me give you another example. Let's say I take an object that's 6,207 grams, and I place it on these 2 balances. And this may help us see why this balance would measure this object to 4 significant digits, and this balance would only measure it to 2. Because if I take this object and I place it on this particular balance, it's going to measure 6,207 grams, because it is able to measure to the nearest gram, plus or minus gram. We're a little bit unsure about that, but we count it, so this is going to have 4 significant digits. Aha, but if I place this object on this balance, this readout only goes to plus or minus 100, it's going to read it as this, or maybe 6,300, depending on how the balance is calibrated or programmed. So obviously, this number is wrong, because we know it should be a 7, but because the balance is only able to measure to plus or minus 100, we've really only made measurements with these 2 digits in this particular measurement.